Hey there! Welcome everyone out there in streaming land. Happy Saturday and happy data to you. Welcome to my stream. Very excited to be here again. Always a good time live streaming data science for the world. The few, the proud, the data streamers. We're like a special super breed of live coders and streamers because, I don't know, because data is just cool. So anyway, I'll dive right in. Start by introducing myself. My name is Carl, and I'm a data scientist in Silicon Valley, California. What can I say about myself? Let's see. I'm not the best looking, the best sounding, or the funniest streamer, but I am an actual data scientist. I lead a data science team at a startup, which is a pretty cool place to be. Get to work with lots of exciting technologies, meet cool people who are into data. But so yeah, going into the live streaming mode here. So I'll start out by introducing the topic that I talk about. I always do a little level setting at the start of the stream. I do go into sort of advanced topics, but I always start out very basic. I hope that if you start the stream at the beginning and stick with me, you'll actually, kind of like be able to make sense out of everything that I'm talking about. That's certainly the hope. So I apologize to those of you who have heard this all before. Ooh, and I apologize if my mic level is a little bit loud. Let me turn that down a touch. Please let me know if there's any issues with the sound quality or anything I can do to make your listening and viewing experience better. Because I'm here for you all out there. So the background. I talk a lot about, today we're going to talk about pipeline cross-validation in scikit learn, and I'll explain what all that is as I get to it. I'll first explain some of the background, which is I talk a lot about something called churn. So I must start by explaining what is churn. And again, apologies to those of you who have heard this before, but churn is when your subscribers, customers, or users quit, or they unsubscribe or unfollow or cancel, whatever you want to call it. Why do they call it churn? Well, someone made up a metric called the churn rate, which is the percentage of your customers that drop out at, generally you measure churn over a month or a year or something like that. We're not going to do churn measurement today, but that's fine. That's where the term comes from. So churn is not just a rate, churn is also a verb. You can say the customer churned, or even I'm going to churn from, Hulu or Netflix or whatever your least favorite series is. I heard a great phrase recently, which is churn and return. Someone coined that term for just like, watching a season of, your favorite show on Hulu and then canceling and then re-signing up again when a new season comes out. So that's what they're calling churn and return in the business. But churn is also a noun. You can say make a churn report, or make a report of last quarter's churns. Or you can even say that customer is a churn. They already canceled their subscription, so they're a churn. But that's only if you're really into this stuff. Or most people, just churn means canceling or quitting. So that is answering the first important question, of the day. Now, I am now answering another important question, which I usually never answer. I'm going to try to start doing this on every stream. It's just highlighting the music that we're listening to. You can see the songs in the upper right. So let me move that thing down a bit. There you go. Now you can see all the songs. And we're listening to no copyright music for Twitch. Not a great name on that playlist, but oh so useful. And it's thanks to Kike Varela Reguero. Give a shout out to him and thank you for providing today's selection of tunes. But that is not about data science. But I do love music. So every stream here, you'll always hear music playing because, I don't know, I just couldn't listen to myself talk for that long without it. So I hope you enjoy it too. All right, back to the data science program is What is Fighting Churn with Data? That is a book that I wrote. It's based on my experience when I was chief data scientist at a subscription economy leader called Zuora, which was like a platform for companies to run their subscription business. And that is how I kind of got my churn expertise, was by working on churn for a lot of Zuora companies. Also, there's a discount code up there. Be sure to note that if you actually want to purchase the book, definitely use the discount code. But you should be able to learn everything you need by listening to this stream and checking out my free code from GitHub, which I'll show you in a few minutes. One other thing, well, the next thing, let me just say, not one other thing. The next thing is, what is fighting churn with data really? Because it's a cute soundbite to say fighting churn with data, but it really means data-driven churn reduction. That means using data from your company, product, or service to actually make a difference in retaining your customers. So it's not just a prediction problem. It's not just a machine learning thing where you predict some output and you're done with it. Really, fighting churn means actually doing something. And the things people do is, well, use your data to improve your product, make features and content that customers love, and use your data to help figure out what they are without doing surveys. There's also marketing. You can do targeted engagement to really send your customers information that they find useful rather than just like spam. And again, use data to figure out what your customers are useful. Then there's something called customer success, which is helping your customers in need. That could be like training or onboarding or even reaching out to them directly. If your predictions are showing a customer is at risk of churning, hey, why not? See if you can help them. And lastly, there's sales and pricing to reduce churn. But here I like to stress, this does not mean giving discounts to reduce churn. That's pretty much the worst way to reduce churn. It's way better to have a tiered pricing plan so that when someone doesn't want to stay on your regular plan, you can downgrade them to your lower tier. Or if they're actually a power user, you can upgrade them. But anyway, that's the way to get the most value from your customers. But don't give discounts when people leave. That undermines your pricing plan. Anyway, so that's what fighting churn with data really means. I just like to put that in there. What's next? Why learn about churn? That's always my little sales pitch, why you might want to stick around and learn this. Well, it is the most common data science problem in the world because every company out there today has a churn problem. That's what I say, because all companies today want repeat or recurring customers. It's not about just a sale anymore. It's about, the life cycle of the customer. But there are some special techniques for churn, which I will help you understand. And it's also a fun way to learn data science, or a really thorough way to learn data science. Because if you study from my code or book, you go from raw data all the way to actionable results. So that is why you should learn churn and data science, according to me. Happy to hear other people's views on it. But failing that, what's next up here? Oh, next is another little advertising. Well, advertising and discount code. There's another way to learn churn now with a real data set. You can actually study the data of my publisher. They made their data set available for people to analyze churn. And this is unusual because most companies will not, make a data set publicly available so that people can study. But that's what this project is. You can see it here. Well, this is what it looks like. It's at manning.com/bundles/fighting-churn-ser, which I guess is for series. And Gold LP35 is your discount code to get 35% off. Here, let's try this link. Did it work? Yep. Link still seems good. So this is what you will see. And yeah, so it's a 3-part series because actually there's a lot of different tasks to do analyzing the data. And so in each part, you kind of get a task, and there's solutions as well. So it's kind of a cool way to learn. You do have to spend money for it, though. I apologize for that, but you know, it's actual data, which is pretty rare to find. And I spent time actually, you know, trying to design it so that's easy for people to kind of go through the different steps. All right, enough self-promotion and advertising. Let's do some, you know, where's the data? Let's actually look at some data. I start the stream by taking a little look at the source data that we're going to work with for the rest of the stream. And this is to get a little bit into the coding straight away, which is always good. Need more coding, less talking, right? So where's the data? It's in a database, and I'm using Postgres just because, well, it's a free open source database that I got pretty familiar with. It also shares a lot of common features in the language, the style. It's like supported by Redshift and Snowflake, you know, a lot of features in those modern databases. So where's the data? This is just setting the schema that we're going to query in. So in the database, we've got customers. If we look at select star from account, there's an account table, and we don't have any personal names or anything about these customers. We only have a few pieces of information, and the real truth is that these are simulated customers. So this is not actual real data. Because remember, like I said a few minutes ago, it's very hard to get real data to actually use to study your practice. So for my book, I actually wrote a simulation. So this is simulated data, simulated customers. Customer 1 uses the product on App Store 2. That's my simulated app store. They were born in 1981 and they're from Russia, I think. Anyway, so we have these simulated details about all the customers. And let's see, how many customers actually do we have? I think I did a short simulation last time. So I've only got 1,400 customers in this simulation, but I think if you run the code from the book, you'll get more like a 10,000 customer simulation. So this was a quick one. So what else have we got? To study churn, we have subscriptions, which shows you when the customer signed up and when they quit. So this is just basic data, background. You can see each customer has an account ID and they can have several subscriptions. So you can see that this customer started on January 15th, 2020, and they quit on June 15th, 2020 also, because then we start with, you know, customer 2. So there's multiple subscriptions per customer. It's called co-terminal subscriptions because the start date of one subscription period aligns with the end date of the other. So lastly, what data do we have to work with? The most important data is actually events. This actually doesn't look very important because it just looks like a bunch of codes. But for each account, we have, whoops, that's not what I wanted to do. We have these codes with a date and timestamp for everything that every customer did in the system. Well, everything we're tracking. And this is realistic for a lot of products and services today. They track events of what people do in their system just to, you know, understand how people use the product and debugging. But we can also use it for fighting churn. Let's see, I want to actually show you more about these events by joining the event type table. Let's see, I guess it's event type. I think it should be an event type ID, right? Let's try this now. Did I get this right? Okay, here we go. So now I've joined the event data on a type table, which shows you what they really are. And now you can see that the events in the simulation are things like posts, unfriending, messaging, replying. So it's a bunch of stuff that people do on a social network. So it is a social network simulation. And so all the data we're going to look at is going to look like we're, simulating, or not simulating. It's going to look like people are using a real social network, and we're analyzing their behavior, their messages, their posts, likes, and things like that to see if they churn or don't churn. So that's kind of the context in everything we're going to be doing, like the backgrounds. And that's my coffee, which there's not really enough of, but I'll try to keep the energy going after the coffee runs out. We'll see how I do. So this is the data we're going to be working with. This is the raw data in the database, but actually we're going to be analyzing a data set. So I've already worked on this data and pre-processed it into a data set. Well, actually, let me back up and tell you how you can get this code and this data. So from my GitHub repo, github.com, Carl24K, fight-churn, you can get all the code from the book for free, of course. You will have to install PostgreSQL and Python. You can clone the repo, or there's actually a pip install option if you want to do a quick start. All the details are in the GitHub repo. And then you'll have to run the data simulation to get this data, and then you'll be able to run all the code. Now, I'm working in a branch to 2021-0911 transformers. I just kind of dated my branch. Let's see, I think I had the web open a second ago. I can show you where to get this code real quick. This is my blog website. I don't update my blog very much. I'll be honest, I'm not much of a blogger. But I do my live stream about every week. It's just more fun than blogging, so what am I gonna do? So this is the main code. I'm working in a branch, like I said. This transformers branch. So if you want to actually see the code that I've been working on with transformers the last couple of weeks, you should go to this branch, and that's where you'll find it. All right. So still too much talk, not enough code. Good music though. And good coffee, just running low. So I mentioned that we have a data set already, and this is an overview of the data set. There is a churn indicator. It says it's a metric, but really this is the outcome variable. Whoops, stay on that slide. And you can see that about 5% churn by looking at this. The mean is 0.05 and the non-0% is 5%. So that's about 5% churn, which is actually not that bad. It's pretty good, kind of mediocre actually. 5% monthly churn, because that's actually like 50% churn per year. Really good monthly churn is like 1% or 2%, but that's pretty rare. So then we've got a bunch of features or metrics in the data set. The first one is like per month, which is for any given customer or account, how many likes did they make in a month? And then there's all these other metrics like new friend per month, post per month, ad view per month. Those are all the different things people do on the service. And if you go down even further, there's things like reply per month, ad view per post. Those are more complex metrics, I should say, or features that we calculated previously. And there's a few other things like the days since new friends and percent change in the number of new friends. That's what this shorthand looks. And so here you can see that, let's see, the average days since someone got a new friend is 7.5%. The maximum is 106 days. So that person had 106 days since their last new friend. And maybe they're unhappy about that. And that might put them at risk for churning or canceling the social network. So that's kind of what the data we're going to be looking at. And in the spirit of less talk, more code, I will do my first quick code example by looking at how to produce those statistics that we were just looking at. This will be a very simple code example, but it kind of lays the foundation for what comes next. So I will now switch to, some code that I left with some weird notes in it. But I want to show you this example of calculating the stats, and I have a configuration for it already here. I guess it's is it this one that says run stats? I guess so. I'm going to try running into it with the debugger. I'm pretty sure I already set a breakpoint in it. So let's see if this works. All right. It has worked. We're now in what's in the book. It's called Listing 5.2 Dataset Stats, and that means it's in Chapter 5, and it's the second piece of code in that chapter. And it's how we're going to make that statistics table. So we pass in the path to the dataset, and for me, it's users Carl blah blah blah. You know, social net dataset. First thing we do is check if the file is really there. That's always a smart thing to do. And in this case, it's okay. Next, I read in the data set into Panda's data frame. And I'm using the first two columns of the file as the index for the data set. We can now look at the data real quick, show you what it looks like. In case you haven't seen a data set before, I mean, you probably have if you're watching this stream. But so we've got the account ID and the date actually together form this index column. And now each other column is a metric. This actually looks like a data set of scores because they're both positive and negative, and they're centered around 0. So this is actually a data set of scores. We'll talk more about what exactly a data set of scores is in a minute, but it looks like I left this code pointing to the score data set before I ran it before. But no matter, we can still run this and, you know, see what it does. So this is actually converting the churn column to a float, which makes the rest of the statistics work. And the real key in this listing is actually just a pandas trick. There's a great pandas function called describe, which you have to know if you use pandas, because it tells you all these great summary stats about your data set. Here you can see what comes out of that pandas function call. And we've already here got a lot of those things that I'm using in the table: the count, the mean, the standard deviation, min, percentiles, and the max. And you can really see, yes, this is definitely a score data set because all the means are 0. We'll explain more about that in just a minute. So then the rest of this listing, I'm actually just augmenting those statistics. On this line, I flip it because I want the metrics in the rows and the statistics in the columns. And then I'm adding these additional statistics: the skew, which is the third moment, the kurtosis, which is the fourth moment. I'm not going to go into the details of this stuff right now. We'll talk a little bit about skew and kurtosis more in a minute, because we'll need them. The first and 99th percentile, and this is a quick one-liner to see how many measurements in a column are non-zero, which is useful for metrics that have a lot of zeros in them. It's typical for a lot of behavioral data where there could be, you know, no one doing something. All right, now I've got all this stuff in my summary, and I'm actually just reorganizing the columns. So now I've basically created the summary that we were looking at in that slide. You can see here I've got my metrics on the rows, the count, the mean. Wow, the means are really all 0 except for churn. So this is definitely a score data set. So we're not actually making the data set summary that we just looked at, because this is a slightly different version. We'll say more about what the scores are in a minute, but I just kind of wanted to get started in the Python code so that people can see. So now I actually save that summary out to a file. That's one of the reasons I put it all in a data frame, because then when you want to save it, you just save it right out with 2CSV. I can show you. Whoops, that's not what I wanted to show you. This is what I wanted to show you. That I just produced this file, the summary stats, and if I opened it up and looked at it, which I won't bother doing, it would look like this one. This one doesn't look the same because this one is the unnormalized data, the pre-scoring data. And we're going to say more about that right now, I think. Because after we review dataset stats, we are going to start going over the topic for today, which is scikit-learn transformers, also known as sklearn. Because when you import it, the import is sklearn. But the official name is scikit-learn. I actually don't know what other people really call it. I often call it sklearn. I don't know if anyone out there has opinions on what they call scikit-learn. So a transformer is an object that represents a stage in a data pipeline transformation. So transformers do things like scaling data to scores, which I just mentioned, and also dimension reducing the data. And we're going to look at both of these applications today. So scikit-learn has some off-the-shelf transformers and some base classes you can extend. And I'm actually extending the base classes. I'm not using the off-the-shelf transformers because I don't really like them. I have my own way of transforming things, and we're going to look at that. But this is the code pattern for a transformer. We're going to see this a few times in the upcoming minutes. You have a heck lot of imports. I don't know why I included these imports. But you generally need NumPy and pandas if you're going to do any of this stuff. And here's those sklearn imports. So a transformer has to have an init function where you can pass in your arguments, shown here. And then it has a fit function where you pass in data, and that is when the transformer is going to do any learning that it needs to adjust itself to your data set. Because a transformer is like an abstract operation. But this is how you customize it to your data, and we'll show that in just a minute. And then lastly, there's a transform method, which is how your transformer is going to transform new data. So that's the code pattern we're going to be using. And let's talk about scoring real quick. That's the first transformer we're going to look at. So scoring is when you rescale your data to a different scale. I guess that's what rescaling means. But you rescale, like shown here. So your natural scale of your metric for something like likes might be 0 to 1,000. And then you're going to have a lot of customers bunched up close to 0 or around the mean. Maybe 100 likes is your mean. But then there's going to be a few customers with 1,000, or 500. But they're few and far between. So your data is not well scaled across this range. Now, when you convert your metric to a score, it will be in a range around 0. Small numbers above and below 0. The mean will be 0 and the standard deviation will be 1, and that makes it easy to compare to other metrics. It also makes it easy to interpret the result of regression. We're going to talk about that in a little bit. And the data is more evenly distributed once you convert it to the scores. Now, these are the formulas that I use for scoring. I'm going to go through these briefly. I've introduced these before, and then we're going to run through the code in just a sec. So if a metric is skewed, which means that it has a lot of high values above the mean and not below the mean, and if we go back to our stats on this data set, whoops, you can see that the skew of many of these metrics is in the range of 4 to 15, except dislike percentages skew of 1. So any skew above around 3 or 4 is pretty skewed, and it means that the max shown here on the right is very far from the mean. It's a simple way to understand it. So what we do in that case is we take the logarithm of 1 plus the feature that is skewed. And that basically rescales it. So if the logarithm makes 10 into 1 and it makes 100 into 2 and 1,000 into 3. So that takes your outliers and kind of compresses them together with the more normal values. Then this next line, S equals, this is the transform metric, M prime. minus the mean divided by the standard deviation. And that's how you get 0 mean and 1 standard deviation, which is the standard normalization or scoring formula. Now that doesn't work for negative metrics. So there's another score formula for positive, negative, extreme metrics, which what I mean is a metric that has extreme values that are both positive and negative. And there's 1 or 2 examples of those, I think. You can also detect these kinds of metrics because they have a high kurtosis. So, which is the 4th moment, which tells you how many extreme outliers you have. If we go back to the data, kurtosis, these are very high kurtosises. I think a 3 kurtosis is considered kind of neutral. It's the kurtosis of a normal distribution. So these are very extremely kurtotic, I think that's the word, metrics. Because they have a lot of extreme outliers. And the thing is, this is true of real customer data. I didn't just make this up in the simulation. So we apply this formula. Again, it's a logarithm, so it compresses extreme values to a smaller number. Because it can go negative, we do this funny transformation where you take the metric squared plus 1 and the squared root. Now that's always going to be positive because we're squaring it. And then we add the metric itself. So if it's negative, we end up very close to 0 because m will, sorry about that, hit the mic, m will be negative, m squared will be positive and a little bit bigger, so you'll basically get back to 0 with this formula. So it puts very extreme negative metrics to 0. The positive metrics actually get pushed out, but then they get the logarithm. So that's how this all works to normalize things. So in a past stream, I already put this into a transformer. So now we'll go through the code that actually does the metric scoring. So this is still review. We're going to get to the new stuff soon, but this is review to kind of make this stream stand alone for anyone who hasn't seen this before. Let's see. So now I want to run the score transformer. I have to like score current with transformer. No, that's the wrong one. I want to do extreme score transformer. Okay, that's the listing that I want. I need to close up some of these other things. I got too much stuff open here. All right, this is the one we want. I just want to make sure I've got a breakpoint near the beginning. All right. This is the listing which actually demonstrates creating a transformer. So I'm going to run this. We're going to hopefully hit this breakpoint on line 83. Yeah, there we go. So I've already loaded the data. Same data as we looked at in the first listing. You can see here it's a data frame with 1,200 approximately rows and 17 columns, one of which is the churn indicator and the rest are the features or metrics. Now, we're going to construct the extreme score transformer with a skew threshold, which is a threshold of when it should apply the transform for skewed metrics. And there's also a kurtosis threshold, which is another parameter that is, in this case, just defaulted. So in this constructor, I really just set those variables. I also note that there's going to be an outcome column, which is the isChurn column. Unlike in scikit learn, I like to pass around my data in one data frame with the outcome column in it. Personal preference. This just sets to none a bunch of variables that we're going to use later. So that finishes the constructor. Now we're going to fit the transformer. And what we're going to do in the fit function is based on the algorithm we just looked at. It has to figure out which columns are going to get the skew and kurtosis transform. Hey, C-Films, long time no see. Yeah, really great to see you again. Let us know how your website is going. I remember you do a Seattle Films website. So what do I use Python mostly for? Well, I use Python really for everything at my day job. We do everything in Python. We do all our machine learning for production systems. Also the services, I should say, that serve our models are all written in Python. So, yeah. What do I use Python mostly for, or what do people do Python for? I don't know quite what you mean, but anyway, glad to hear your website is doing great. So this is the fitting part of a score transformer. In this case, we're going to drop the outcome column because we don't need it. And we're going to save that result into a new data frame. Now here I'm actually making a copy of the columns in the data, and there's a reason for this, which is that later I have to make sure that any new data I transform has the same columns. That's why I make a copy of the columns. You have a second project you've been working on called McFly. Uh-oh. I'm afraid to hear about this one. Tell us about McFly when you have a moment. Anyway, here I measure the minimums of all the columns, the skews, and the kurtosis values. So if I look at this now, self.skews, this is going to be a named series. This is what I mean by named series. So every element has the name of the metric, and then these are the skew measurements right here. All right, McFly is a calculator, a new programming language being developed with Python. Oh, that's interesting. A new programming language developed using Python. Sounds cool. So in this code, this Python here, what do we do? Okay, next I check which columns are we considering as skewed, which is the ones where the skew is greater than the threshold and the minimum has to be 0. Now for the other columns, I call them fat-tailed, which is kind of a colloquial term for extreme valued in both directions. We look at those greater than the kurtosis threshold and also not the skewed columns. And these next lines, I reduce the skewed column list to only the ones where it was true. Because remember, this is a Boolean series, so they're not all true. But after this line, skewed columns equals self.skewed columns bracket self.skewed columns. That's a kind of a weird code statement. But now I've only got the skewed columns, only trues. So that's the result of that. All right, I better keep moving. Okay, so current McFly's slogan is it learns from the past but looks to the future. Okay, that's like any machine learning. We hope it's going to do that. Currently, McFly runs on top of Python. All right, well, nice shout out for the McFly programming language. I'll have to look that up. Now, in the rest of this transform, what we're going to do is actually figure out the transform values on the fitting data. So in this case, well, I'm going to copy the fitting data, and then for the skewed columns, we're going to apply that log of 1 plus the metric transform, and that's how we do it. Just like that. And you can see the metrics that we're applying it to here. Add view per month, dislike per month, etc., etc. Got to move faster. So I'm going to get out of this loop. Let's see. I want to get this continue button here. And now for the other extreme value columns, we're going to apply the log of the column plus that square root function I just explained. Let's see, what libraries do you mostly use in Python? Well, definitely scikit-learn, as I announced in the title of the stream. We're doing a lot of scikit-learn and a lot of pandas and numpy, basically. Those are like the three. That's like the triumvirate of data science pandas libraries, right? Scikit-learn, pandas, and I guess everything's kind of built on numpy. What about you? What Python do you use? All right, now what I need to do is actually, we're going to calculate the means and the standard deviations of all the metrics. Whoops, and that was the end of the fit function. So if I look at the transformer now, here we can go in here. I now have the means saved in my series. Now these are the means of the transformed metrics after applying those log, transforms and what have you. And that ends the fitting of the transformer. Now let's actually see the transformation step. Stepping into the transformer. Okay, well, we first copy the data. If there's an outcome column, drop it, because we're not transforming it. Next, I'm going to make sure that all of the columns in the transformers column list are in the data. Because if that weren't the case, there'd be a real problem. It's like the wrong data, Whoops. All right, now this line 64 is going to reorder the columns to the same order as the ones used in the transformer, which is another good safety check, just in case you're getting some data that might be in different order. Because some of these other operations are going to depend on it being in the right order. Now this applies the skew transform to the columns that need it. We found these skewed columns before. And this applies the extreme value transform to the high kurtosis columns identified before. Libraries you must use are string, enum, and data class. Oh, really? Okay, that's interesting. You must do real Python programming, like writing code that does stuff. I do data science Python programming, which is usually passing data from pandas to scikit-learn and back again, and doing things like that. Yeah. Huh. And data class. I don't even know data class. What is data class? I'm getting a little curious. All right, this next line, 72, very important. This is where we subtract the means and divide by the standard deviations. And because S is a pandas data frame, and the means is a vector, and the standard deviation is a vector, this is all vectorized. So we just divided by the means of all the columns, subtracted the means of all the columns and divided by the standard deviations. And that was that. And lastly, if there is an outcome column, we have to add it back to the return data. So now I have the data transformed to scores, as we can confirm by looking here. All right, now it looks very scory. This is actually the data we were looking at earlier. But anyway, that's what scores are supposed to look like. And that is the end of our first transformer example. And then I save it out to a file after transforming the data. And I also save the transformer. This is actually key. I'm also saving the transformer as a pickle file. And so that means I'm saving out all those, mean values and all those other things that I was like, I calculated, so that we can reuse this transformer later. That's a key point. And if I look, you can see in my local directory, these are the score file I just saved out. We're not going to bother looking at it because I think my computer crashes every time I open one of these. And then this is the pickle. So 12K, very small, to save that transformer, because it doesn't save the data, it just saves the parameters. Alright, data class library is this module provides a decorator and functions for automatically adding generated special methods such as init and reproduce or repeat to user-defined classes. I should get more up on stuff like that, because things like attribute modifiers and accessors, I don't really know the right way to do a lot of that in Python. So I have to be honest, I am not a good Python programmer. I'm passing. I always tell people I originally wrote my book I did all my churn analysis in R, and then I had to convert it all to Python when I wrote the book. Okay, so that was the listing for the extreme score transformer. And that's the end of my coffee, so I'll have to do the rest of this stream without more caffeine boosts. The next thing we're going to talk about is the dimension reduction algorithm that we use. And that is averaging with a loading matrix. And this is a toy problem example. I see here, toy problem. So in the toy problem, we have 6 metrics and 5 accounts. You can imagine that there are more accounts after that. Oh, do I prefer R or Python more, and why? That is a very good question. I actually like both, but for different things. Basically, if I'm going to do any kind of production code or code that I'm going to share in a repository with my coworkers, or models that we're going to run in production, I like to use Python because it's a standard for doing that kind of work. And also you can be object oriented, which is really good for refactoring and organizing your code. At the same time, I really like R. I like R for all kinds of analyses, data munging, and any kind of quick and dirty analysis that I have to do. Now, most people like to do that in a Python notebook. I actually don't like Python notebooks. Anything other people do in a Python notebook, I will do it in R with RStudio, because it's just such a more intuitive syntax for selecting and indexing data. So, which one is better for math, statistics, data analysis, and data visualization? It's not actually like that. They're both great for math, statistics, data analysis, and data visualization. Python is better for managing large code projects because you have object orientation, and there's just a lot more standards around doing large code projects in Python. R is better for if you just have to work by yourself and do something with data. It's going to be way faster in R, I feel like. So yeah, they're both good for math, statistics, and data analysis. It's just Python is more collaborative production code for me, and R is more like, I'm just analyzing something. So that's my take on Python versus R. Not everyone will agree with me, but that's my take. Now let me finish explaining this algorithm. So we're going to average together the first 3 metrics, login, read, and reply, because they're correlated. Whoops. That's not what I wanted. And the way we're going to average them is by multiplying them all by 0.33 and adding them together. So we multiply these 3 columns by the first 3 weights and put them in the first column. And then the next 2 columns, send and write, we multiply by 0.5 weights to average them to get this column. And finally, the like score, in this made-up example, we don't average it with anything, so it just has a 1.0. And this is called the loading matrix, and it is a way to encode the metrics you're grouping together and also apply the operation by matrix multiplication. So that is how I, like to do, that is the way you do dimension reduction in a linear model. Now this is kind of a toy example. This is what a real data set and loading matrix looks like in one case study that I worked on, and it's described in the book. So here we've got, more than like 70 metrics in the data set, but you have a very large number of them are highly correlated. So this big square is a whole bunch of correlated metrics, and they all get grouped together. The littler square here are metrics for like another part of the product, template gallery. And this other block is metrics related to making data sources. So real data sets can be very large, but a lot of the metrics will be highly correlated. So a real loading matrix is going to be a lot bigger and group a lot more metrics together, which is why it actually makes sense. It doesn't make any sense with a really small data set, but how do we find the groups? You do something called hierarchical clustering. So you work on metric scores, as we just learned about. You identify the most correlated metrics and you merge those together by making a loading matrix, as I just illustrated. And then you keep repeating this until all the correlated metrics are merged together. Now, let's go through that algorithm. This is I did this in the previous stream, but I'm going to go through it now because we're actually going to do new stuff in a couple of minutes using both of these kinds of transformers. So this is the metric group transformer. So let's go to the code. Listing, let's see, metric group transformer. Yep, I've already got this one. So I was doing it in the last stream. And if you saw this all in previous weeks, please bear with me because we're going to be on new stuff soon. Okay, woo, where am I? I don't think I had a breakpoint. Where the heck am I? I want to put a breakpoint up here so we can start at the top. Alright, let's start at the top. Do over. No breakpoint was set. Alright, we gotta have some breakpoints in this code, or, you know. Well, now I'm stopping, just like as before. I'm gonna put the breakpoint right after I've already loaded the data. But note that this time I'm loading scores. So I'm loading the scores that we made in the last code listings. This works together. I'm initializing, did I just say initialating? That was a nice doozy of a mispronunciation. So I initialize it with a threshold. The threshold is set to 0.65, which means that metrics with correlation above 0.65 will get grouped together, and those with correlation below 0.65 will be left separate. So in the initializer, I do very little. I just save the correlation threshold, also 1 minus the correlation, the outcome column, and a few none variables for later things. C-films, does churn have a formula? Well, churn rates do have a formula, and the churn rate is always defined as the number of customers that churned in a given time period, like a month or a year, divided by the customers that you had at the start. And I've done entire streams on calculating churn, but today's stream is not about that, so I will just advise you to look on, the old streams or on the YouTube channel, and there I go really at length into calculating churn, or churn rates, that is, which I think is what you mean by does churn have a formula. Now I'm going to show you the fit method of this transformer, which basically has to figure out which columns are going to be in the groups and create the loading matrix for the transformation that I showed you earlier. So let's see. First, we're going to, yes, the snake case. Isn't that the standard in Python? Personally, I'm actually a camel case kind of guy, but Python is all this, snaky case with underscores. So let's see. Here I'm just keeping track of what columns are in the metrics. Here I'm actually calculating a correlation matrix for the data. Actually, let's look at that real quick. So this shows you, this is the correlations in the raw data. So you can see that every metric is 1.0 correlated with itself. But for example, like per month is 0.57 correlated with new friends, 0.65 correlated with posts and ad views. So a lot of these are pretty correlated, and actually these are above my 0.65 threshold. So these should get grouped by the algorithm. But so we're going to use the correlation matrix to figure out what metrics are really similar to each other. Okay. And let's see. The next, whoops. Oh, god damn it. I wanted to step into this method. Do over. Sorry. Killing it. Because this one, find correlation clusters, is really where it actually does the algorithm. So I'm going to back up. Backing up. This is like my third do-over on this listing. Here we are. Right back at that breakpoint. Aren't breakpoints great? This is where we actually do the algorithm of finding, which are most similar. It's actually really easy because I described a kind of complicated algorithm, but actually I just use these functions. This is from SciPy. Let me just show you real quick. I'm importing from SciPy the cluster module or package, sub-package. I always forget what these things are called. Linkage, F-cluster. These are actually what does the algorithm. So first we compute a dissimilarity matrix by taking 1 minus the correlation. That kind of reverses the correlation so that the things that were most highest numbers before, the 1.0s, become negative. Or 0 rather, and the things that were least correlated now have the highest numbers. So that's just the way the clustering algorithm is defined. It wants to use dissimilarity rather than similarity. So now this one function actually calculates, linkage and square form calculates how similar or dissimilar the metrics are. And then this function calling F-cluster actually takes the thresholds, which we set earlier, and forms the groups by seeing how close they are. But it's returning a list of labels. This is just a list of labels. You can actually see 1, 2, 1, 1, 6, 11. That's the return value, which is the group number for each metric. Hey, Tixil 2020. I'll watch your stream tomorrow as now is midnight. All the best from Switzerland. Well done. Oh, cool. Well, glad to hear you're watching over in Switzerland. You know, I worked at the ETH in Zurich, or ETH in Zurich once, during my PhD years as a grad student, and I loved it. I thought Zurich was awesome, and the ETH was really nice. So I have a small connection to Switzerland, so good night. I realize it's late over there. Right, so this algorithm, back to it. This is returning the labels of each metric, which group. Oh, wow, okay, I'm glad I got a reaction of you. I guess you've heard of the ETH. I guess everyone over there has. It's kind of like MIT here. It's a pretty famous institution. So I was lucky to be there. Good times, younger days. Now the next thing in the algorithm is actually to take these labels and relabel them to make it more intuitive. I'm actually just going to run through that here, and we'll look here and see actually the group assignments for each column. So now you can see add view per month, like per month, and post per month were all assigned group 0. Unfriend per month and unfriend per new friend were assigned group 1. So these are the clusters or groups of metrics. Message per month and reply per month are group 2. And then all the others are, individual. Let's see. See films with more information about Python. According to the Python Got's website, there are certain rules we need to follow while naming a function in Python. Ooh. Yep, write the function name with all lowercase characters. Rule 2, do not use upper characters. Yep. Rule 3, use underscore. Yeah, those are the rules for Python. That is right. And I grudgingly follow them. I really, in my own code, I like to use camel case because it's just hard work typing all those underscores. Every underscore you type, you have to shift and reach, it's like shift and reach for that underscore. And it's just like, camel case, you just shift and touch your next letter. So you don't have to do that extra underscore reaching thing. But I follow the convention when I must. Grudgingly, I'll admit. Okay, the next part is actually making the loading matrix from those labels. I think I'm going to skip over this one too. Whoops. Oh, I had a breakpoint in it, so I'm not skipping over it. It basically goes around in a loop. It basically makes an empty loading matrix, goes around in a loop, and fills it in according to what we had in the labeled column df, which was really the answer. So this is going to show us the loading matrix we've created. Oop, I haven't created it yet. Now I've made it. So now this should look like a loading matrix, and this is showing us, so these are the weights for averaging these first 3 columns together, and I'm now calling it metric group 1. This is for averaging the next 2 columns together, calling it metric 2. So this is what a small loading matrix really looks like. It's not quite as much of a toy as like my previous example. Whoops. The toy problem in the slide, but it is a pretty small loading matrix compared to a real problem. And I'm planning on making a more realistic data set sometime. Rule 3, do not start the variable name with a number. I think I'm good on that. Rule 4, do not use special characters. Yeah, well that's, yeah, definitely also true. I don't even know if Python will let you use special characters. It does let you use camel case. I know that because in a lot of my own code, I still write, if I'm not sharing it, I will write camel case in Python. I'm that bad. That's like a dirty secret. I just admitted online that I write camel case function names in Python when no one else is going to look at my code. Anyway, back to this algorithm. We now have the loading matrix. And now let's look at how we actually apply the loading matrix. So this is actually assuming we have score data and we've already fit the transformer. Pretty good tune. Keeps me moving. As usual, I'm going to drop the outcome column before working on it. Next, I'm just going to convert the score data into a NumPy array by calling to NumPy. And in this same one-liner, I'm also reordering it to be in the right order as the loading matrix data frame. And then to actually perform the grouping and averaging operation, it's actually a matrix multiplication. So I'm going to multiply this NumPy array to group by a loading matrix. And that's it. So you can see the grouped, if I open up and you can see the grouped ND array only has 12 columns. I'm showing down here. But the original data to group had 16 columns. So that's the dimension reduction part. Let's see. Rule 6, do not use reserved keywords as variable name. For example, keywords like class, for, def, is, else, try. Yeah, although I have seen people make some unwise choices about using words for, reserved words for function names and module names and stuff like that. It can really get you, although you shouldn't really have a function name like class. It's just like too short, but people will do crazy stuff. So anyway, that was the grouping algorithm. And yeah, now I'm going to re-add the outcome column, and that's basically it. The rest of this, I'm going to save the data. This is now the grouped and scored data. And we're also going to save this transformer that I fit. So this is a new pickle transformer. And I'll just take a quick look at the results here. So this is my newly grouped and scored data. And now this is the transformer that I saved in a pickle. I know it's kind of hard to read all this stuff, but hopefully not too bad. Now, let's get back to the program, and we are approaching stuff that'll really be new. Whoops, this is back to the code. All right, the next part of the stream, we're going to get more advanced and look at model pipelines. So it's nice to use these transformers one by one, but in the examples I just showed you, I fit a transformer and then I used it immediately afterwards, which is, kind of not a very realistic, use case. Well, I guess you might do it, but more realistic is you're going to fit it and save it for later. And this is an example of how you can actually use your pipelines, your transformers together with a model. So you use this pipeline object. You define your stages as tuples with names and an object in a pair, and then you pass them to the pipeline object. And then your pipeline object is going to have this sklearn functions like predict defined on it. And in this case, calling predict will both run the pipeline transformations and do the prediction, which is important because when you predict with a logistic regression, you need to have transform data. Now this is the last review listing. This is what I did in my last stream. I'm going to go to that now. And then we're going to do some new stuff, but this is key step. Transform plus forecast. Hopefully I have a breakpoint set in this one. Oop, in fact, it's crashing. Ooh, sweet. Transform forecast. What did I do? I renamed some. I was like messing around with this. I might have broke something. So now I'm actually going to go straight into live hacking because I'm going to try to fix my code. What did I do? Let's see. For classes in Python, rule 1, we need to follow the camel case convention. That's true. They're all supposed to be camel case. Let's see. This is the transformer I'm supposed to be using. I do have a breakpoint in it. But what is my error message here? Transform forecast is missing one required positional argument. Oh, new data path. Oh yeah, I changed the signature on this method. But I have to update. I was messing around with this after the last stream and I added a new parameter. So now I actually have to go into my configurations and add it. I think this is what I'm supposed to be using. So yeah, I need to give it a new data path, which is going to be, because the scenario here is that I already have, let's look at the code. The scenario here is that I already have a transformer for the score and a transformer for the dimension reduction saved. And also a logistic regression saved. I have everything saved here, and I'm going to reload them and then forecast on some new data. So this is going to be running the algorithm on the brand new data. What do I think of the camel case convention for objects? Actually, getting back to CFilm's discussion, I think it's good. And actually, let's look at my objects. Let's see, did I close up all the objects? I had a few objects open. So here we go. Let's see. Transform new metrics. No, that's the wrong one. I want to get back to one of my actual transformers, which was in chapter 6. So for this transformer, here's my class, and I have followed the convention of camel case. Although, oh wait, I'm not using camel case. I'm using sentence case. What's the difference between camel case and sentence case? First letter. I capitalized the first letter, so actually I'm using sentence case and not camel case. So I think that means I violated rule 1, Python rule 1 for class naming. Pascal case? Is that what it is? I thought it was called sentence case. Alright, well it might be more than one name for it. But anyway, I'm supposed to be going through this new listing, which is going to show you loading a new data set and transforming it with a saved transformer. So let me kill this. See if I've fixed it now. Alright, so the dataset path here is SocialNet 7 dataset 2. And the new data path is going to be SocialNet 7 dataset 2 underscore current, which is basically dataset 2 is the historical data that we have for these customers. And then the current is like the new data for the current customers. You know, what are they doing lately? So in this listing, I'm going to reload the scorer, which is our first transformer that we looked at. I'm going to reload the reducer, the dimension reducer, which is the next transformer we looked at. And you can see these if we go into them. Oh wait, I haven't reloaded them yet. These are just the paths. And there's also a logistic regression algorithm. So I'm reloading them, reloading the scorer. We're not going to have an outcome column in our current data, so I'm actually going to reset that. That was a little customization I put in last week. And we're going to reload the reducer. And we can look at these now quickly and just confirm that these are the objects that we created earlier. So here's the scorer. We can look at these mean values, and these should look kind of familiar. These are the metrics and the mean values we saved before. And similarly, we can look at the reducer. And let's see the reducer. Whoops. Well, that doesn't show us much. We can look at the loading matrix. That's the most interesting part. And this is the loading matrix that we had saved before. So it's, you know, all packaged up in our transformer. So C-Films, you need to refactor McFly to use Python conventions. Well, that's always some work. There are some auto formatters too. You might want to look into that. In my team, we were just looking at using Black, which is the name of an automatic formatter for Python, which will make all your code follow Python conventions. So you might want to look into that. It's an option nowadays. Now let's see. In this code, now I've loaded my scorer and reducer, and now I'm also loading a logistic regression model, which I have previously fit as well. We're going to look more at fitting one of these in just a few minutes, but you can see it has a parameter called C and these coefficients. The coefficients are like key to the output of logistic regression. Now I'm going to create the model pipeline, which is, basically I make this list. I made a list of the tuples, scorer, reducer, and the logistic regression model. Then I'm going to reload this new data here. This was the whole point of this exercise, is I have some new data. Now this data is not in the form of scores or groups. So here you can see these are the unscaled metrics, like per month, ranging from like 3 up to 3,000. Wow, that's a lot of likes. Someone does a lot of likings in this simulation. New friend per month. So it's not rescaled to scores, and it's also not grouped. Now that's actually usually a pain for logistic regression, that you have to do all this stuff to prepare it for logistic regression. And then when you get new data, like a validation set, you have to redo your transforms exactly the way you did them the first time. So that's really the whole point of this approach is that it saves your transforms to use them again. So now I'm going to call model pipeline predict proba, which is the prediction function on the logistic regression. Let's take a quick look and see. We should, if I put breakpoints in here, we should hit my breakpoints. Yeah, so I've got a breakpoint in the fit function. But what about in transform? Yeah, here's a breakpoint in transform. And I also want to have a breakpoint in my other transformer, which was the extreme score transformer. Let's make sure we have a breakpoint in the transform function. Really, I just only want one. Okay, so back to the listing where we're working. Now I'm going to call predict proba on the pipeline, and all together it's going to score the data, dimension reduce it, and do the logistic regression forecast. And I think it's going to hit my breakpoints that I set. Let's cross fingers and see what happens. All right, there we go. I am in the code. So now I am in. Let's look at the call stack here. You can see, let's see. I'm in pipeline predict proba, and I'm calling transform on my first transformer. You can see that in the pipeline, here's the loop in the pipeline object. It loops over the transformers and calls transform on each one with the previously transformed data, and then finally it calls predict proba at the end. So now we already stepped through this transform function like 10 minutes ago, so I'm not going to go through it again. But now we're going to hit the second transformer. This is now in the dimension reduction transformer. Again, in the call stack, I'm in the same loop here. And now I'm calling the transform function that we also went over pretty recently. So I'll just step out of this method. Now I'm back in the pipeline. I'm back up in the pipeline predict proba function. And that's the end of the transformations, and now it's going to call predict proba and return that result. I just want to get out of here, actually. And now these are my predictions. And these, if you don't know what the output of predict proba looks like, it is the probabilities for class 0 and class 1 in 2 columns. So you can see all the probabilities for class 0 are low, and the probabilities for class 1 are high, but that's because this is an unbalanced data set. So that's what's going on here. So let's see, Python org website says to use class names should use the cap words convention. Well, I think cap words is basically what I was doing. Yeah, cap words sounds like the convention I was applying, so beats me. Alright, now in this listing, we're just going to save the forecasts out. And that's basically it for this listing. So what I've shown here is that you can save your transformers and then reuse them with new data, and it just makes it a lot easier to rescale and dimension reduce using, the same approach as you used previously. So that's what we're doing here. Now we're going to get into some new stuff. This is actually getting into the new topic for today. Sorry it took me so long to get there, but like I said, I like all these streams to be kind of freestanding so that you can just watch this one and you should know everything you need to know, or you should learn everything you need to know to kind of follow along. The new thing we're going to do today, or new for me actually, maybe all of this has been new for you so far, but for me, cross-validation with a pipeline is going to be really new. Now, cross-validation, as you probably know, well, I'll go over this again in a minute, but it's testing your model to get the best parameters. So models have parameters. That's what I say here. Brilliant statement. The regression has a loss parameter, or C parameter, which controls how much it penalizes non-zero weights coming out of the regression. Transformers have parameters too, as we saw. The scoring transformer had these thresholds for skew and kurtosis. Dimension reduction had a threshold for correlation. So those are some parameters too. Now parameters should be cross-validated. This is my great illustration of cross-validation. You're going to test parameters. You're going to test like one group of parameters by backtesting. Backtesting means testing with cross-validation, but on time-separated data, so that your validation set is in the future from your training set. So you backtest in multiple different time periods, and you get like an average accuracy, like AUC is a standard accuracy metric. And then you're going to do different parameter versions, and then you're going to see which one has the best AUC or other accuracy metric, and then you're going to pick the best one. Now, let's go over a cross-validation, because this is going to be the basis for what we're doing with the transformer. I'm going to do it. First, I'm going to do the non-transformer cross-validation, show you just what cross-validation looks like. Then we're going to write a new listing, which will be the pipeline cross-validation. All right, how's that for a plan? All right, let's go back and look at listing 9.5. Which is the old cross-validation listing. I'll put a breakpoint here. Let's see. I have to find a configuration for this if I don't have one already. Well, the easiest thing to do will be just to copy this configuration and call this cross-validate no pipe or something. This is supposed to be chapter 9, listing 5. Alright, gonna do the cross-validation now. Let's see. Let's see, is it working? Is it working? Yes. All right, the first thing I do is call this prepare data function, which actually just gets the data ready for using it in the prediction, which is to separate the outcome from the data. So you may recall, so here I'm loading scores. Yeah, so I'm loading this, and then I'm reading the CSV, and then I'm taking out the is churn column and making that into my y variable. I subtract 1. Let's see. Which means I'm modeling it as retention and not as churn, so that positive coefficients will correspond to being retained. It's kind of a long story, but I flip the outcome in this regression. Not necessary. And then we drop the churn column from the x, and so the y is just the churn and the x is just the metrics. I use a time series split object, which is like cross-validation, except the validation sets always have to come later in time than the training data, which is meant to simulate real conditions in out of sample machine learning problems. Now, I add these score models, lift and AUC. Lift is a kind of intuitive measure of the accuracy. AUC is the area under the ROC curve. Many people will be familiar with that already. Then I make the logistic regression model. Here, this makes the object, and I use a penalty called L1, solver liblinear, which makes this ridge regression, if you've ever heard of that. And we're also going to include an intercept term. Now, I mentioned that there's this C parameter. I didn't really explain it in this stream, but it controls how large the coefficients are allowed to be. It's like a penalty term. I don't call it the penalty because it's actually like 1/C is the penalty. It's a little bit complicated. But you need to test different values of the parameter. So I'm testing in a logarithmic scale, half smaller each time along this range, which I kind of learned in advance is a good range for this kind of problem. Okay, next I make a grid search CV object, giving it my regression model, my score models, which were how I'm going to score it, and then I say return the training score false, refit false, which means I'm not going to refit with the best parameters. I guess I'm planning on doing that later. Then I call the fit function. And now it just ran the cross-validation. Let's see. What did it say? Fitting 2 folds for each of 9 candidates, total 18 fits. And that was it. That was actually the cross-validation. And this is actually taking the results of the cross-validation. So let's take a quick look at this. So this is showing you what happened in the cross-validation. We're going to look at more of these later, I think. This is each value of the parameter that was tested, 0.64, 0.32, blah, blah, blah. Then these are the lift. Mean lift 5, 4.6, 5.6. These are the mean lifts. And somewhere over here, we're going to get the AUCs. So these are the AUCs, ranging from 0.87, well, for the highest ones, really just around 0.87, 0.88. And then when you get too high in the C-param, the AUC goes to 0.5, which is really bad. So this is like the worst possible AUC. And these are the ranks. So number 3, or index 2, is the best AUC, 0.879. And that was the parameter for C.16. So that's the result of this simple cross-validation with just one parameter on the logistic regression. Right, so that shows you how to do a cross-validation on logistic regression, just the logistic regression parameter. Now, the next thing I do actually in my own regression, this is actually some of my own custom code, is I test how many weights are non-zero for each fit of the model. And I'm going to step over that right now, but I'll show it to you in the result. This is my own test. And here I show at the end that the number of non-zero weights in the model starts out at 10 and then goes 8, 7, 6, 5, 2. And you see when it gets down to 2, actually something bad happens to the model and it stops fitting very well. But interestingly, the number one AUC model actually has only 7 out of the possible 10, I think it was actually 11 or 12 total weights that are non-zero. So actually maximizing the accuracy is usually done by reducing the number of weights that we use to model the data. And that's the whole point of cross-validation for logistic regression. Okay. And anyone out there on the stream, let me know if you have any questions about this, because we're going to get on to something even more advanced next. Let's see, my last little function here is plot regression test. That's my own thing. I'll just step over that, assuming it works. And let's look at the plot I just made, which actually shows you a lot about the regression. Here it is. Interesting. So what happened? I'm going to open this up bigger so you can see. Oops. Alright, so this shows what happened in the regression cross-validation that we just ran. So this shows you the mean AUC. Wow, I think the AUC went off my chart. Oopsie. That's bad. I need to fix that. Why did I do a maximum of 0.8? And this shows what happens to the lift. And this shows the decreasing number of parameters. Wow, let's fix that, actually. You know, this is live coding. So we had a problem with the scale. Let's go back to this cross-validate and see what's happening in this plot function. Oh yeah, I set it maximum of 0.8. Bad move. Alright, let's just rerun that listing now that I've changed the maximum AUC on that plot to 1.0. Now it's just going to run the whole thing really quick. Alright, back to look at the file. Alright, now we can see a little bit better. Well, now you can see that the AUC is above 0.85. It's hard to see that increase. It does look like it's increasing a little bit and then starts decreasing. And then it gets really bad. These is like the model fails to fit at those more extreme levels. And yeah, so that's kind of the result of cross-validating this C parameter. You can see how reducing the C parameter reduces the number of non-zero weights or coefficients that come out of the regression. So that's what this cross-validation does. And that was what I wanted to show you, but now we're actually going to do something more exciting for me, because I've never done it before. We're going to cross-validate the pipeline parameters as well, because remember, my pipeline transformers have their own parameters. There was the threshold for the kurtosis and skew, and there was also the threshold for grouping in the dimension reduction. And I don't really know if I ever chose the optimal values for those, honestly. I just kind of picked them because they seemed reasonable and they gave me a result that I liked. But I never actually checked if they helped the accuracy. So to do this, you make a pipeline in a similar way as before. You define some steps, including both a transformer and your logistic regression algorithm. Then you define a parameter grid that includes not only the C parameter for logistic regression, but also the transform parameters, that you had in the scoring algorithm and the dimension reducing algorithm. Then you make your grid search CV passing in the pipeline instead of the logistic regression. And then you call the fit function just as before. And I was looking at this example. I'm showing like a link to an example I was looking at. It's kind of where I got this stuff. But now I'm actually basically just going to dive in and try to make my own version of a transformer pipeline. So this is the new, now we're finally at the live hack. This is the most exciting part of every stream, when I will actually attempt to code something new that I've never coded before. And Scout's Honor, I have never tried this. Or maybe I'm supposed to do my right hand for a Scout's Honor. I don't know. Anyway, I was never a Boy Scout, but this is new for me. So let's get into the live hack, and we're going to make a new version of this cross-validation, but using transformers. So I'm going to basically define a new listing in the end of this chapter. So it's going to be listing 910. So I'll just let's just say like a new file. And we'll call it listing 910 cross-validate transformers. How about that? I don't know. Sounds like a good name. So this is my new listing, and so for every one of these listings I have to have a function which is the same name as the file. So cross-validate transformers. And as usual, we're going to have a data set path. Whoops. Now, what else am I going to need in this? Well, I actually had some imports shown here, didn't I? No, I didn't. Well, let's see. I think I can go to my other pipeline listing and copy the imports. Like any good programmer, I'm going to do a lot of copying when I make a new, when I do some new code. It's pretty rare that you start from scratch, right? If you're a programmer, copy paste is like the name of the game. So let me just find the right stuff to copy paste. None of this. I want my last pipeline, because this one is going to have, the pipeline object. Let's see. Copy these to begin with. I don't know if I'm going to need this. I think I need the other imports from defining transformer. No, actually what I need is my own transformers. So that's what I'm going to do. I need to say from listings dot chapter 8 listing. Oh no, I need to actually go back to chapter 7. Extreme score transformer, import extreme score. Okay, these are my own transformers that we looked at earlier. So I went over this code previously. And also from listings chapter 6 listing 66 metric group transformer, I'm going to import my hierarchical cluster dimension reduction transformer. Alright, so that is partly what I need. And now I also need my logistic regression. Here I'm actually going to look at this one again. I think I'm going to need actually all of these, actually. Okay. Alright, I think that kind of ends what I need as far as importing. Now, I'm going to need to look at my examples soon. There's a very good song by a band I like, Suburban. It's very cool of them to put it out there copyright free. Let's see. Let's really start getting this code to work. Let's look at my example. Okay, I'm gonna make a pipeline. I'm gonna say pipe equals pipeline. First I'll say steps equals, this is gonna be my list. Scorer, and here I think I just pass in the class. Scorer is going to be extreme scorer. Reducer is going to be the hierarchical cluster dimension reducer that we defined earlier. And lastly, log reg is going to be, let's see, logistic regression. I'm a little bit wondering, where do I pass in the other things I need? And what is wrong with this line? What isn't it like here? Expected. Statement expected. Oh, I see. I have one too many parentheses here. Now, where do I pass in the parameters for logistic regression? I'm actually going to go to my example here. So there's an example that I'm working off of, which is this example of doing a PCA transformer and a logistic regression. So here they just put in the class. That's interesting. It does not show me how to actually pass in parameters. That might be a problem. But maybe I can pass them in the parameter grid. I'm not really sure. Let's see. Alright, next I need to define my param grid. Okay. Param underscore grid. Now, I'm gonna have one which is c underscore log reg, and this is supposed to be, well, I'm gonna check over the same range as I tried in the regular cross-validation. So I want to try this range of c parameters. Now, oh yeah, this is a dictionary declaration, so I use colon, not equals. Now, let's get in the parameters for my other transformer. If I go to extreme scorer, I need a skew thresh and a kurtosis thresh. This is going to be skew thresh underscore scorer, I guess is how this works. And let's try, well, my default, I think, what did I say it was? The default was 4. So I'll try numbers like 2, 3, 4, 5. And my kurtosis threshold, the default was 7. So I'll try some values around that. Let's actually just put this in. I think I need a double underscore here, actually, looking at the example. Double underscore separating the parameter name from the pipeline object name. And these ones, I said I was going to try a range like 3, 4, let's try 6, 8, 10. I don't really know what a good range is. And the kurtosis threshold, I was using 7. So let's try like 5, 7, 10, 15. So that's kind of like some range of the thresholds there. Now we have some other, there was another parameter in this guy, which is the correlation threshold. So here I'm going to use correlation threshold underscore reducer. And before I was using 0.65. So let's try things like 0.4, 0.5, 0.6, 0.7, 0.8. So I'm not trying the exact value I was using before, but this will try a whole range of values. Alright, so this is going to be my, my pipeline. Let's go back to my example. Okay, I create the pipeline. Pipe equals pipeline steps. Now I'm going to use the time series split like I used in my other listing. Let's go to that one. This is my old cross-validate because I want to use the time series split like I usually do. And I also need the number of test splits variable. I think I was just using this like 3 before, but I'll get that in there later. Okay, let's see. Let's see, so I think the final important line is really just to call the grid search tcv.fit, and now I'm going to call it on my pipeline. This is really putting it all together. Let's look at the old cross-validation. Oh, I need the score models. Right. I want to use, let's just try with AUC for now. I don't want to deal with this stuff about the other stuff. Oh no, wait. Yeah, okay. So I need to make the scorer. Again, copy pasting. No, I'm not ready to do this fit yet. This is actually wrong. I need to make my score models. I'm just gonna use AUC. Okay, now I need to make the grid search CV object. Let's see if I've got everything I need here. I'm going to pass in my pipeline instead of the regression. Okay, scoring equals... I think I can actually just say ROC AUC here. I'm going to use a time series split for cross-validation, verbose equals run, return train score false, param grid equals, oh, param grid. Great name for that variable. Refit, I'm actually going to say true, so we can look at the best. And then finally, we call gsearch.fit on the prepared data. It's got to be X and Y, so let's get back to that in a minute. I need my X and Y. That's what's definitely missing here, is turning my data that I pass in a path into the required X and Y. And here I'm doing it in this XY prepare data function, which I guess is really fine. I can just reuse that for now. As you may recall, it's just, although I'm gonna have to double check the use here. Let's actually go into this and maybe just do the parts that I want. I mean, this is basically loading the data. I think I just want this part. Because I don't want to do this extension of group score, which is what I use when the data is already converted to groups and scores. But now, because I'm using the transformers, I want to pass in the unmodified data. So I'm going to go back to my new listing. And yeah, let's just get the data up front. Data underscore df. say data set path, so I'm just loading it. And in my data, I have this isChurn column. I am going to model this as retention, and then I'm going to drop the churn column. So this is going to be my little data preparation in this script, so we can see how that works. And so it's not going to be using the group data. Okay, looks like I need MP, or whoops. And let's see. Okay, I think I'm actually good. I might be ready to run this. Except I wasn't really sure about those other parameters. I think I want to pass the other parameters to my logistic regression right here. In particular, I wanted this penalty and the solver. Or maybe I need to make like a closure for my logistic regression with these parameters. I'm not really sure about this. Let's see if I can just pass them in. I think this might actually be what I want to do. Like, what if I just pass them in here and I pass a logistic regression object? I'm actually not really sure, because that's not what happens. Of course, the example that I'm looking at is a lot simpler. Oh, yeah. No, actually, no, that's what they did. So they created their logistic regression and then passed it here. Okay, so this is right. I'm good, actually. Okay, and I'm going to go back. I'm going to actually match what they do. I will go here and say logistic equals just like they do in their example. Now, am I supposed to... Is that right? Oh, typo. There we go. Now what, let's look at the example again. So, okay, they also create the other objects. Okay, so I'm actually supposed to create these first. I'm gonna actually go back. I'm gonna say scorer equals extreme scorer. And reducer is going to equal my hierarchical thingy. And I guess I just set these with like the default parameters. And I assume it's gonna, I don't actually know how it's gonna I guess it's just gonna set these parameters directly on the objects before calling fit. Or maybe it expects these to be parameters of the fit. It's not really clear to me. So I'm not really sure how this is going to work. I might have to figure out some of this and do some additional research. I don't know if anyone out there has ever done this before. But I think I'm ready to try it. I'll put a breakpoint here. And lastly, I need to make a new configuration. If you remember, I have these configurations for all the listings. And if I'm going to have, now that I have a listing 10 in this chapter, I need to make a new entry in this JSON, which has the name of the listing. And then it needs to have any parameters. This is just the way I like configure my code to run. So it's going to have a parameter, which is the data set path. Let's make sure I used the right name, because these all have to match up in my new listing. Yeah, data set path. And now we also need an end test split parameter. All right. I'm just going to call this like 3. That's what I was using before. All right, I think I'm actually ready to run the listing now. And let's duplicate my old configuration and call this cross-validate log reg pipe. This is chapter 9, listing 10 is what we'll be doing here. Cough drop, losing my voice a little bit, but doing okay. So I'm excited to finally test this listing. Let's see how I did. The first test will be if I configured everything right, if I actually reach my first breakpoint. Let's see. Nope. I screwed something up. What's it saying? Cross-validate got an unexpected keyword argument, dataset path. Whoops. Is that not what I had here? Oh, I had dataset path. What? Data underscore set path. Whoops, and this will have to be underscore. All right, my first bug, I think, hopefully got past my first bug for the live hack. All right. Now, I've actually made it to my first breakpoints. This is good. Now I'll try loading the data set, okay, which works. Make my Y from the isChurn column, subtract 1 from it, so it's actually then retention. And then I'm gonna drop the isChurn column, and now I've got my X, which should basically look like my data. Yep, that's the right data. It looks pretty much like it looked before. It looks a little bit... I think I was looking at the current data before, but who cares? All right, now we're going to see if my code works for the pipeline cross-validation. Let's see. Create a scorer. Okay. And create... Whoops. Uh-oh. Looks like did I miss a required parameter? Let's see. What's it saying? Missing a positional argument, core thresh. Alright. Well, I guess the easiest thing to do is just put in... I should go back and just create a default, because this does have a reasonable default for this is something like 0.4, which is kind of a low correlation, but not super low. So I'm actually going to try just doing this again, now that I have a default built in here. Okay, heading back to my breakpoint. Loading the data. Create the scorer, create the dimension reducer, create the logistic model. Now I make my list of steps, named as such, and now my parameter grid. I'm going to put a new breakpoint here, because this is where I'm trying to get to. Well, now is the moment of truth. I'm going to try building this stuff and see if it actually works. Made my pipeline, made my time series split, and now I'm going to make the grid search. You know, I actually didn't put any lines after the fit, so I think what's going to happen now, if it works, is it's just going to run and not do anything. But let me just run this next line and we'll see if I get any errors or crashes. Yeah. Invalid parameter, blah, blah, blah. Oh, god damn it. Alright, what was my error? Okay. Value invalid parameter C for estimator pipeline. Score, blah, blah, blah. Alright, I've done this wrong. That's weird. This was actually based on the example. Logistic __ C. That's how this person did it. And they define logistic as logistic regression. And this is supposed to be the name. I don't know. I thought I did the same, unless I had some typos. All right, second bug for the live hack is, oh, I see the, Maybe I need to use this exact word. Maybe it's supposed to be the model name. Let's just try it like. Okay, I wanted to copy it from the example. Logistic. Oh, I've got these all backwards. That's the problem. All right, I've got everything backwards, so none of these are going to work. All right, let's straighten this out. It should be reducer underscore underscore. Whoops. All right, and these are supposed to be scorer. All right, thank you, but no thank you, my pair programming partners out there. If you're all my pair programming partners, someone should have noticed that I have those all backwards. All right, let's try these. All right, so now I've got the name of the pipeline object first and the parameter second. All right, but remember I had the problem that this code was not going to do anything even if it worked. So let me go back real quick to my old cross-validation. And I want to get the results out, which is basically just like this. Let's just save the cross-validation results so that at least I can, look at them afterwards and make sure this worked. Result, yeah, grid search.fit results. And then what do I do? I'm going to want to save it out, I guess, to look at it later. I usually like to look at these things later, and it's a good habit for aspiring data scientists. Do look at the results. I'm going to call this the pipeline cross-validation. I'll put another breakpoint here. All right, this is what is this? Take 3 or take 4 on running my new function. Cross-validating the transformers, hopefully. Let's start it up again. All right, at the first breakpoint, I'm just going to skip over all this setup and go straight to the interesting part that we're trying to get to. Here I'm creating the pipeline, creating the time series split, creating the grid search. Now the moment of truth is, will this crash or will it run? Let's see, crossing my fingers. I think it's working. Just a console. Oh, no, that's not working. Oh my god. Oh boy. Wow, I think this is like the worst crash I've ever had on a live stream. Whoa. Okay, I'm gonna have to stop this. Stop. Okay, man. Wow, that was definitely unexpected and not very graceful. All right. I don't even know if I can tell what the hell is going on in this. Wow, what an ugly dump of a stack trace. Let's see. Oh, key error. Is churn not found in axis? Ooh, why do I need... Oh, I know the problem. Oh yeah, I created these objects. I need to have no outcome column. That was the problem, because my objects were created allowing the option that your outcome column would be in the data. So I just realized what the problem was. Because remember, let me go to this object. In the extreme scorer, I'm expecting an outcome column to be named is churn. But actually, it's none. And because in this case, I've followed the sklearn convention and switched the data to be in the format of X and Y separately. So in this case, I want no outcome column in both of my transformers. All right, I think that's going to fix this bug. That was my own oversight. So let's just put in those new parameters and try it again. Alright, once again, gonna skip to the next breakpoint. I should really just put a breakpoint right here at the fit function. That is the moment of truth. Ready for the next moment of truth? Crossing my fingers properly now. Let's see. Oh, hey, it's actually working because it's calling my breakpoint in the transformer. Wow. I'd better get all the breakpoints out of this file now. That's okay in the wrapper function. So this was in my extreme score transformer. That's good that it managed to call this. Now I'd better go also to my my metric group transformer. I also want to make sure there's no breakpoints. Like here. I don't want to have this breakpoint. I don't want to have any breakpoints, except in the wrapper function is okay. Alright. So where am I? I'm in the extreme score. I'm just going to like hit go and get back to the console. Oh man, still barfing. Ooh, stop. Not good, not good, not good. Alright. Now, why is this not working? Infit transform. None type object has no attribute transform. Alright, now I'm really debugging. Let's see. Fit failed warning. Estimator fit failed. See, maybe this is not so bad, but actually remember how in the output I was failing for C below whatever that number was. Let's take a look again. So my model was failing for C below 0.04. So actually, let's fix that. Learn from our past mistakes and only try these values for the logistic. Now I'm actually just gonna run it. I'm not sure if that was causing all the failures. There might be a lot of other errors here. I don't know. Let's just see what happens. Kill that last run. So only testing over what I know are somewhat healthier parameters. I don't know if that's going to fix it. It's also a little disappointing that it didn't handle the bad parameters internally more gracefully. Alright, still not working. Definitely still not working. Alright, so having some problems here. Line 50 in fit. It's not liking something about this line. I'm not really sure. The new method seems to be having a problem with the skewed column transformation. I'm wondering if this is another problem with kind of like inappropriate. I wonder if it's another problem with inappropriate parameters. Fitting 3 folds for each of 500 candidates, totaling 1,500 fits. Okay. Estimator fit failed. I wonder if these are just warnings. If these are really errors. I'm going to try a much narrower range of parameters. Like, things that I'm more certain are going to succeed. let's just try a very narrow range around the old one. I think the old skew thresh was 4. The old kurtosis thresh was 7. And the old correlation thresh was 0.65. So I'm just going to try narrower ranges in all these parameters and see if that's fixing my problem. Let's try it. Nope. Shoot. Something definitely not working here. Alright, just debugging in the live hack. I'll see how long I'm going to work on this for today. I know if anyone else out there has done this before and you've got some great tips, happy to hear it. Okay, let's go up to the first error. Fit failed warning. Estimator fit failed. The score on this train test partition. Details. Nation. Let's see. None type has no attribute transformer. So now where is this none type happening? Now, are these all warnings or errors is the other thing I'm not really clear about. Attribute error. None type object has no transform. Still not quite sure what is causing this error. Just want to see if what happens if I just let it run. I'm honestly not really clear if these are warnings about some of the fits failing or if these are errors about the whole thing not working. Really failing a lot. Alright. I don't know, did anything happen here? I think I'm gonna have to go back into debugging. Yeah, definitely didn't work. Okay. Let's try debugging again. At the fit method. Just want to briefly check my pipeline. Pipeline has an object called steps, which allows you to access the different parts of it. Just want to make sure these are all the right things. So my pipeline has scorer. And this looks right. Kurtosis threshold 7, skew threshold 4, outcome column none. Reducer has a correlation threshold like it should. Output column none. And logistic model is a logistic regression. These all look pretty reasonable to me. Let's see if it'll actually catch on the error, because the debugger will sometimes just stop on each error. Let's see. See, now I think it's splitting out all these errors, but it's actually not. I don't really really clear what it's doing. It's not actually crashing. I mean, it's supposed to give me a break on any actual error. It's doing all these warnings. All right. Let's see. Basically returned a whole bunch of nans. Let's look at the result. Oh, that's where it's actually failing. I think it's actually failing on my own line. Let's stop this again. I just want to go straight through this and see what actually comes out of the fit function. Oh, debugging is fun. It's not always so smooth, you know. I'm really doing some new coding that I've never done before. I'm sure there's some little gotchas here that are preventing this from working, and that are giving me these rather heinous warnings. Estimator fit failed. The score on the train test, blah, 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 blah. What the hell is going on here? This shouldn't take too long. I don't know if anyone out there has any fun data science or programming things to talk about while we're waiting for this to run through and get to my breakpoint. Well, one thing I should do... Okay. None type has no attribute transform. Now, why is this actually happening? Let's look in the... Okay, I actually caught on pipeline fit param steps. Scorer, reducer, logistic. Why are there no fit params? That actually doesn't really look right. Did I not pass in the fit parameters? No, I did. I mean, this is my param grid here. That's what it's supposed to be. Let's see. This is fit. I'm calling fit on the grid search CV object. Okay. And it has a parameter grid, which is the one that I passed in. If I'm doing that right, that's still an issue. Like, I don't know if my syntax for passing in the parameter grid is right. That might actually be my problem. Let's see, going back to my example on sklearn, pretty much following what they did. Oh, I pass a pipeline into the parameter grids to the grid search CV object. I wonder if it's the way I'm passing in the scorer, actually. There's a good thing to check, because in my old listing I was passing in the scoring in a different way. Let's look at this one. See, here I passed it in a dictionary. Let's try this. I really don't know what's going wrong here. It could be... Let's see. Here I'm going to pass in my score models, which is going to be ROC, AUC. I wonder if that's part of the problem. What did I do here? CV refit. Oh, I think for refit, actually, I also need to give a... Boy, I got all these random things open. Refit, I think I need to name my scoring algorithm here. That could have been a problem. I'm not sure if that's the actual problem that I had. I don't know. Who wants to take bets? I'm going to bet that's not the actual problem. But it might be the actual problem. See, looking in my example, I might have to like follow their approach. They don't even specify what the accuracy metric will be. Let's try it. If this starts spewing junk, I'll just stop it. No, that's not it. Nope. Alright, not figuring out this bug or bugs yet. How long should I go on for? I'll go on about 15 more minutes, maybe, till 4:30 my local time. And if I can't solve this bug by then, I'm just gonna give up for the day. And I'll like figure it out on my own time. I was hoping I would get something working. Usually I do. Let's see. No, I'm not actually sure if my scorer is supposed to have like a special method for like setting this. I don't know, my errors just don't give me anything. It said fit failed warning. Estimator fit failed. Infit. Fit transform one cache. Now why doesn't it work? Fit transform. None type object has no attribute transform. I don't know. Could try to set a breakpoint here. You can do shit like this. Like, what if I put a breakpoint in right here? Fit method ability to supervise transformation. I don't know. I'm gonna try putting a breakpoint there and just like, you know, take a look, see what happens when I get there. Maybe it'll give me a clue of what's going on. Alright, now what is self? Self is an extreme scorer. Oh, here's a problem actually. Oh, my scorer has no Y method. Maybe that's my problem. Because this is gonna try to call fit on my scorer. I think that's the problem. So this is passing. Okay, fit parameters. Ooh, is nothing. Why are there no fit parameters? I wonder if I have to add the parameters to the fit function and also add a Y variable. That could be the problem. Let's try this. This is a little crazy. I'm going to go back to my transformer objects and try to change the signature on the fit function, because maybe I didn't have them set up right for what I'm trying to do here. Let's see. This is my old fit. Oh, look, I have a Y equals none. And I also, let's try, so I had the Y, but I didn't have actually the parameters. I'm going to try putting these on the fit function. That might also be my problem. And I'm ignoring the Y because this is an unsupervised transformer, but I'm just going to try taking the parameters. I'm actually going to say none for these. Because I set them in the constructor, so I'm a little bit like, why am I setting them again? So if skew, I'm just going to check if these are not none, and then I'll take them, you know, from those passed in. So I'll view this as an opportunity to reset them by passing them into the fit function, which is maybe how this is supposed to work all along. Again, like maybe I've just been doing this wrong the whole time. Okay, so this is my 710 extreme score transformer. I also need 6.6 metric group transformer. Now here we have the fit. Okay, I'm also already taking a Y, but let's also add the correlation threshold as an optional additional parameter. I'll just do something similar. I was kind of wondering exactly how those parameters were going to get set on my transformer, because I didn't really provide a mechanism to set them. So I think this might really be a necessary bit to make this work. So I'm just going to copy these. I should really refactor that, but screw it. Let's just try to get this to work. All right, so now I'm more matching that signature. Like what I saw when I dug into my debugging output was that the fit function wants an X, whoops, extra space there, a Y, and then the named parameters, which is going to override whatever parameters were given in the constructor. So this is like take 8. Hopefully this is the right way to fit a transformer pipeline, or cross-validate a transformer pipeline, or rather my transformers have to be ready for cross-validating the pipeline. So let's see. Okay. Alright, this is my next breakpoint. So now I'm self extreme scorer. Let's try stepping into this. What are the fit params? But the fit params here are empty. That I also don't understand. Why are these empty? Where do these fit params come from? I feel like I've got something wrong here. Call, args, extreme scorer, keyword args. I'm a little bit unsure about where are my parameters with blah 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 fit parameters. I feel like they're not getting passed in. Fit param steps, score reducer logistic. Why don't I have any steps in here? I'm going up the call stack here is what I'm doing. For those of you who have never done this kind of debugging, I'm trying to figure out, I feel like I should have some parameters in here. I'm not even sure where I am. What is this function that I'm in? I'm in fit and score. Whoops. Whoops, just lost my place there. So here's my pipeline. Here's my keyword arguments, which are... Here's my parameters, which those look like the right parameters to me. All right, here are actually our parameters in my keyword arguments. Now, where do they get lost? Now, in this next function call, my keyword arguments, okay, still has parameters, which look right. Logistic, reducer, scorer. Now, in fit and score, my fit parameters, this is where I got lost before. What the fuck is wrong with my parameters? Whoa, this is some long doc string. Fit and score is supposed to have parameters, which are right here. Okay, these are the parameters that I passed in. And what happens to them after this? Parameters, dict or none. Parameters to be set on the estimator. Okay, that's how it's supposed to work. Fit parameters. Parameters that will be passed to estimator fit. Well, that's a problem. Because my what's the difference here? Parameters to be set on the estimator. Maybe that's how I'm supposed to do them. Parameters is none. I'm trying to understand this. Alright. Yeah, I hear my dog in the background. He's getting bored of me live streaming. Adjust the length. I feel like I'm doing something wrong with how I'm passing in my parameters. Still not sure what I'm doing wrong here. And again, if anyone out there has ever made their own scikit learn, transformers and done cross-validation, hey, Leo Fire. First time chat from viewer. Am I reading your name right? I think it's Leo Fire. How's that sound? How are you on Python? And debugging. Clone parameters is good. Estimator set params. Clone parameters. So maybe my estimator also doesn't have a set params method. Leo Fire is the correct pronunciation. Okay, I was kind of messed up, but not terrible. Maybe my transformers need a set params method. That might actually be the problem. Let's see. I want to stop at that breakpoint on set params and see. So what is my estimator here? It's my pipeline. Set params. Steps. KW args. Alright, now these are actually my correct parameters. This is actually kind of cool. Now I'm going to see how the pipeline does it. If attrib in parameters. Oh, cool. You got really into data science and machine learning? Right on. I've been into it for a little bit longer than the past 6 months, but yeah, glad to have you here, and let me know if there's any way I can help you learn about it. Now this looks right, actually. This is the part where these are my names. Logistic underscore. So if underscore is not name, okay. I have underscore in it. Wait a second. Underscore not in names and name in names. What is names? Oh, is scorer, reducer, logistic. Okay, so what is my name? Reducer. This is kind of, what is this doing? Well, let's just see about this set params. So I've still got the params. Valid params equals get params. I'm just trying to look and see if this is actually like setting parameters on my things, and how does it actually work? Man, I don't even know. Let's see what happens on this line. See, I'm wondering if my object needs a set param. So what is subparams? Okay, so this is calling on the logistic. Valid params key. Key is logistic, set params, subparams. Okay. Alright. Now I'm on the... Okay, now I'm on the object, which is my reducer. Valid params key, set params. And valid params is a dictionary. Reducer. So yeah, I wonder if my object needs a set params function. That could be my problem, actually. What happens if I call this? Or is this just like, where, I mean, what function am I even in now? Is this just like an object level function? I'm trying to figure out where I am. Set the parameter of this estimator. Okay, as well as nested on objects. The latter have parameters of the form component underscore parameter, so that it's possible to update each component. Valid params equals self get params, which are correlation thresh output column. Okay, this actually looks like it's really doing it. I actually now think, oops. Okay, self core thresh. So what? It was actually, this actually didn't work though. Because I'm supposed to be changing the correlation threshold to 0.55, and it seems like it actually didn't do it. Oh no, now it's doing it. Self set attribute key value, core thresh 0.55. Okay, valid params key. So this is actually working and setting my parameters now. So now what's the problem? Now this is going to try to set the parameters on the next object. So now I'm in my extreme scorer, and it should be setting my parameters. I'm just like stepping through this to try to understand what's happening. I don't know if any of you are following along with this. I'm deep in setting the parameters on my transformer pipeline object to try to figure out why the fuck they're not working. So now I'm actually going to set the curt thresh parameter on my object to the value, which I have said is 6, which I think this is working. And now I'm setting the other parameter, skew thresh. Okay, Leo Fire, hoping to use scikit learn one day. Well, I hope that day isn't too long from now. I'm sorry this isn't like an intro to scikit learn. I guess, honestly, this would qualify as kind of like an advanced, in-depth. Like, I'm way in-depth in scikit learn here. So earlier in the stream, I kind of gave an intro, so hopefully that'll be helpful. But, see, now this looks like it's actually working in that I have self here is my extreme scorer object. And I have set my thresholds. So I'm actually setting the parameters on the objects like I intended to. Cool. Yeah, I have a lot of streams up that do start from more basic, points in scikit-learn. But today you really came in when I'm really off the deep end and in over my head. So why is this not working though? So I've actually figured out I'm successfully setting my parameters on my objects. So that's all working. Why is it not working? Well, there's no fit parameters. Now who's fitting? This is fitting extreme scorer. Oh, so it's self-fit, self-transform X. So this is self-fit. Now this is, I'm going to keep stepping through this until I find out what is crashing. I hope this isn't, too, down in the weeds for everyone. But you can just listen to the music if the coding makes no sense. So, columns, I just want to check that this is all working. Self.columns, yeah, that looks right. Minimums, skews, kurtoses. Let's just look at what these numbers are, because I'll be able to tell if these are like the right kind of numbers. All right, these look like the skews of my data. Okay, this you got enrolled in Big Data Analytics Masters. Ooh. Pretty sure you'll have a lot of opportunity to learn and use scikit. Yeah, you're probably just starting out with more introductory stuff. So what have you been doing in the first semester? I would have thought you would have gotten into scikit-learn first semester, but maybe you start out with, more basic stuff. I actually feel like this is like working. So there I've returned from my fit, and now I'm going to go into transform. Oh wait, I think I might have found out the problem. Fit has to return itself. I think that's my problem. Did you just see what happened? I don't know if anyone was paying attention to that, but if you look at oh shit, where was it? It's calling transformer dot. I was on this line dot fit dot transform. And the result of fit. I think that's my problem, actually. Let me go back. Let me look at my transformers. I think this is an error in my fit function. Oh, this is my problem. I think I solved my bug. Seriously, I think this is it. This is my fit function, but if you look, my fit function returns nothing. I think this is my bug. I need to return self. Sorry, I knocked the mic there. Noob move. But in that function, it was calling object.fit.transform. And that means that the returning of the fit function has to be the object itself. I'm pretty sure this is my bug. Seriously. I know it took me like an hour, maybe. None of you have been watching that long, but it took me a while to get to this. Let me go back to my other transformer. Shoot. Woo, too much crap open. Close, 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 close. Boy, I don't even know. I'm in the deep guts of Python here. Barfing out. All right, I need to go back to my other transformer. Now, the hierarchical cluster transformer also needs, I think that's my problem. I was not returning self. I wonder if transform is also supposed to... No, transform has to return the data, but fit has to return self. Okay, I'm just going to try running it again from the top. So this is my listing from the top. Let's get in there. I think I might have figured it out. All right, now this is all the data loading, setting up the pipeline, setting up the cross-validation. Skip all that. Okay, so your first semester is pretty much about Python, R, Bash, and Hadoop. Oh my god, why are they teaching Hadoop? Hadoop is kind of like a 10 or 15 year ago technology. So I think they're crazy for teaching you Hadoop. They should be teaching you Spark if they want to teach you, big data nowadays. So you're an economics graduate and self-learning programmer. Ooh, yeah. That is tough to catch up with the CS people who already know all this programming. But it'll really exercise your mind, I guess. It's the one good thing. All right, I want to clear out this breakpoint, and I want to just run to my next breakpoint. Where am I? Let's just keep going. I don't want this breakpoint anymore either. I don't want this breakpoint anymore either. I might want them again if this doesn't work, but let's see. How am I doing? Oh my god, it's working! Oh, really? They said Hadoop is a widely used NoSQL environment? I don't know. I thought Hadoop is based on, a lot of storing data in your database, or physically storing your data in a big storage architecture. Spark is like a big memory architecture. Hey, Trill Frags. You're choosing to bust your ass in engineering undergrad. Want to do some sort of data analytics science masters. Cool. Cool. Yeah, some colleges actually have a data science undergraduate now. I know the University of California, Berkeley does. Yeah, it's good to get in as much math and programming as you can in your undergraduate. And my story, I took a long path to be a data scientist. I started out as an electrical engineering undergraduate. Then I did a master's in CS and got interested in machine learning. But back then, there was no such thing as data science. So I just did a concentration in AI and then a PhD in machine learning. So that's the long route. I don't know if you want to go that route. But hey, I think my thing is still working. Because if you notice here, my program is running. And it's not spitting out errors. So I believe I have gotten my transformer pipeline working. My bug was not returning self in my transformers. Oh my god, it really worked. Wow. All right, this is a big moment in my life here. I've gotten my first transformer pipeline to work, and this is going to hopefully make a data frame from the results. Let's just see. Let's look at the gsearch object in the debugger. CV results is what we're going to look at. Yeah, I don't know. It looks like something. Let's make a data frame and it'll be easy to look at. All right, let's look at the results. All right, I really got it to work. All right. So this is showing the time to do the fits. So these are the parameters for logistic C, the correlations threshold for the dimension reducer. It's moving over more. And let's look and see what were the AUCs. So, row 3, it's actually ties. Row 3 and 5 are tied on the best AUCs. Leo Fire, starting early matters a lot. You're 23 years old and can't even find internships in your city. Ooh, what city are you in? And well, internships can be competitive, it's true. And I'll be honest, I hire interns at my company, but we have kind of high standards. Even for the interns, we look for interns who can already program, already do some data analysis, and know basic machine learning algorithms. And then in their internship, they're going to learn more how to work in a production environment, like working on collaborative projects, using source code control. Oh, circuits and signals. Yeah, I did that. I was electrical engineering as an undergrad. Trill Frags. Wow, man, I don't remember all that stuff. All that circuits and signals stuff, that is a long time ago for me. But it's good brain exercise. You do a lot of math. Yeah, So you're mostly doing, I guess, programming. Oh wow, cool, Leo Fire. You live in Istanbul, Turkey. Wow, isn't it late for you? It must be like 1 a.m. This is like your after bar hopping, listening or something. Okay, here they asked for 3+ experience for entry-level positions. Now that actually doesn't make sense. That's like an oxymoron. It's not an entry-level position if you need 3+ years of experience, is it? So there's actually a lot of ties for the best AUC, which is probably because some of my parameters were pretty close to, like, you know, other ones. So these might come up with equivalent solutions. And the best AUC we're seeing here is 0.8146. And if you remember earlier when we looked at the other cross-validation without the pipeline parameters, it was only doing like 0.79. So this did actually increase the AUC. Oh wow, it's 2:45 a.m. for you. Yeah. After course chill time. Oh, well, I'm glad you consider it lucky to discover my stream. I'm not sure everyone feels that way. You pretty much have to like Python and electronic music to like my stream. And in case you haven't noticed, I'm not like good looking or funny or anything like that. But I am relatively good-natured, if not good-looking. How about that? All right, let's do a better cross-validation. I want to look over a wider range, like of skew thresholds, like 2, 4, 8. Let's look at, and I want to look also kurtosis thresholds, like 4, 7, 15. I want to like make an actual impact. And let's look over a wider range of these parameters as well. Maybe I should try fewer logistic C values to make this go faster. I never really did any fun stuff with hardware, I guess. Never really a hardware guy. Or it just never came up. I did do some like labs in my undergrad electrical engineering. That was a long time ago. We did like, some labs. The internet is filled with good-looking ladies and gents. Data science is sexier, in your opinion. Thank you. Glad to hear it. Yeah, I'm not good-looking, but I am a real live data scientist, so I don't know. All right, let's try this cross-validation again. I should have actually been running this while I've just been like talking. All right. So what was I gonna do? I want it to run faster, and I'm gonna zoom in on a narrower range around where I think the best logistic parameters are likely to be. So now I've only got 3 values for each of my parameters, but they're more widely spaced. Let's see. But I'm really cross-validating my pipeline transformers, which I've never actually done before. So for me, even though I've been doing this for a while, I'm like, oh, I'm Mr. Professional Data Science. I've never done this shit before. So you've got to keep learning throughout your career. It's kind of what this is showing. All right, it's still running. And okay, it finished. Oh shoot, I didn't like stop and look at the results. Well, I save out the results to a file. I'll try opening it, and hopefully Microsoft won't crash my computer. All right, if my stream crashes, it's because of Microsoft Excel. Because a lot of times, as soon as I open up a file in Excel, that's when my stream starts crashing. All right, let's sort these results, and then we'll look at them a little bit more closely. I want to sort them by the rank, so I get my best result first. Hey, stupid Microsoft. All right. Okay, this is actually looking okay. Let me make it a little bit bigger for the benefit of those of you who are, looking at this on smaller screens. What What do I think about DataSpell IDE? No, I've actually never heard of it. But I'm not very experimental in like my IDEs and stuff. I've been using PyCharm for a long time, and lately I've been hearing that VS Code is the cool new IDE that I should be using. But I'm still sticking on PyCharm. So let's look at what happened here in this cross-validation. I want to, let's see, freeze the top row. And let's see, let's just wrap these texts around so y'all can read this. Okay, so the best AUC it found is 0.815, which is good. It's better than we had before. In the earlier example, I was only getting like, I think 0.79 or something like that, if I remember correctly. And it's using the correlation threshold of 0.5, which is actually lower than the correlation threshold I was using before. It's using a very high kurtosis threshold and a 8 skew threshold. So it's using higher kurtosis and skew thresholds than I was choosing myself, and a lower correlation threshold. See, now that's what that was the whole point of this exercise. Stick as much, yeah, it's good to stick to one IDE and learn more about it. And yeah, I mean, for Python, you pretty much got PyCharm and VS Code are the main ones. I honestly have never heard of DataSpell, but maybe it's a good new one. I'll ask the folks on my team if anyone's heard of it. But I think I'm basically going to call this a success, because I have actually achieved my goal, which was to make a cross-validation pipeline, get it to work, and actually discover if the parameters were any better, and if it actually improved the AUC. 0.815. Let me check my old AUC. This was the old result when I was just cross-validating the logistic regression. It went a lot faster. So anyway, well, let's not bother with that. I think I'm going to wrap up the stream, actually, because I'm going on like 3 hours, which for me is kind of a long stream. I didn't think I'd spend so long debugging that code, but it just goes to show, read the documentation. And what was the lesson that I learned? The lesson that I learned is, when you make your own pipeline transformer, it'll look like this, and don't forget your fit function has to return self at the end. That was my big bug. It took me a lot of digging, and I remember I was going deep into the code to figure out what that was. But anyway, I'm going to call this a successful live hack and get off my stream. This was the part where I say I'm doing a live hack. So yeah, so I'm going to wrap it up. I'm going to call it a day. So thank you all for hanging out with me, keeping me company while I learned something, which was doing cross-validation. And thanks for calling it a good job. Please follow me if you're actually into this. Actually, oh, Leo Fire, you already followed me, I see. I think I missed that. I was so busy. But thanks for following. And Trill Frags, hopefully you'll follow too if you're still out there. You seemed into data. So, my summary, going back to the way beginning of the stream, is that fighting churn is about targeted interventions, improvements, engagement, and support. Metrics summarize your customers' events and subscriptions. In data science, we commonly call those features. I call them metrics a lot when I work with, marketing or, non-data scientists. Now, a transformer is an object which encapsulates a data pipeline operation. Now, what are the data pipeline operations we looked at? One is scoring, which is rescaling metrics to a more comparable scale. And another one is dimension reduction, which is merging correlated metrics. Well, that's how we reduce the dimension. That's my dimension reduction that I was using. There are other things like principal component analysis, which are a lot harder to interpret, in my opinion. Okay. The pipeline is a combination of transformers and possibly a model. So earlier, actually in this stream, we only looked at pipelines, the model at the end, but you can also make a pipeline with just a bunch of transformers. So that's totally legit also. Cross-validation is testing different parameters on out-of-sample data. That's what OOS stands for. And a transformer pipeline is what we did today. You can cross-validate your transforms and your models simultaneously, which was my big exercise, my new learning experience for today. Kind of getting into that, really in-depth, sklearn techniques. So that's the summary. And don't forget, my big learning was, do not forget to return self at the end of your transformers fit function. That was my big bug for the day. All right, how do I wrap up here? Okay, my live stream schedule. My stream Saturdays, 2 p.m., my local time. Why Saturdays? Well, I've got a full-time job and kids, a family, all that shit. So on weekday evenings, I'm not streaming, and I got a day job. So Saturdays is it for me, but hopefully people can join at this time. Let's see. All my streams go on-demand video to YouTube. Just throwing that out there in case that's ever more convenient for you. And, oh yeah, I'm announcing there's a new project you can get from my publisher, which is actually a real churn analysis data project, where you can get real data provided by Manning Books, my publisher. And you get their data, and then I wrote a project where you can analyze that data in different stages. Now, if you're actually at all interested in the project, do use that discount code. So that's the discount code for the live project, so you don't have to pay full price. Unfortunately, it's not free. It does cost money, and it's not that cheap, I would say. I don't know. But anyway, it's a cool project using real data. So shout out to check that out. And of course, this is the book that I wrote. If you're really interested in getting in depth into all this churn and Python stuff, you can get the book. Also, if you're going to do that, definitely use the discount code, because the book is unfortunately not cheap either. I don't make the prices. My publisher sets the prices. But yeah. So yeah, I think that's it for today. Let's see, what else do I have here? Please follow me on Twitter, Carl24K. That's where I give updates on churn, data science, streaming. Don't worry, I don't really talk much about my personal life or anything. So that's it. All right, my next stream, I think I'm actually going to do the live project. So this will actually be a different subject. I think I'm done with cross-validation transformers, although maybe I might go over it. I'll see if there's anything else to do on transformers. But I think I'm done with transformers, and I'm going to actually stream the live project I just talked about. So I'm basically going to start at the beginning of the project and go through to the end over several streams and try to eat my own dog food, so to speak, and make sure that I can actually do my own live project, which I should be able to do since I did it when I wrote it, so that should work out. But yeah, so that's pretty much it for today. What else can I say? Thank you to everyone who joins. And if